Good morning. Today I am going to start integration of product of two functions, which is done by the method which is known as integration by parts. This is actually the product rule of integration. You know the product rule of differentiation, where two functions, when their product given, we differentiate first, multiply by second, then differentiate the second, multiply by first, and two results are added. Here integration by parts is not like that, but similarity is just the product of two functions taken into consideration, where one of them will be referred as the first function. How to decide the first function or second function, that I'll let you know. But suppose in our problem this is our first function and this is the second function. Then the rule states that it will be fx, the first function, this multiplied by integration of gx minus derivative of fx integration of gx dx. Okay, I mean here product of derivative of first and the second function is there, this product is integrated again. So it is better to say it is first function into integration of second minus integration of derivative of first into integration of second. Okay, this product has to be considered. For example, when I'm going to take this product, x sin x dx, by taking x as first function, this minus derivative of x integration of sin x whole dx. Integration of sin x, all of you know, it is minus cos x 1 into minus cos x dx. This plus cos x will be there, sin x plus c. A question automatically arises, why have I considered the function x as the first one and sin x as the second one? Actually, it follows from this notation or convention, whatever you say, that is called islet. In islet, I stands for inverse function, L stands for logarithmic function, A stands for algebraic function, T for trigonometric, and E for exponential. Okay, so whenever you find the product of these functions are there, then the first function will be decided in accordance with the sequence. In the sequence, which one comes first, that will be considered as the first function, which one comes second, that will be considered as second function. There is no third function existence here. All the product of two more functions were there, we could have taken that as the second function. That we'll discuss functions. So in our problem, x is algebraic. See, that's why it is taken as first, because it is product of algebraic and trigonometric. Trigonometric comes later than the algebraic one. Algebraic is x, trigonometric is sin x. So this one is second function, this one the first function. This is our example 1. If we consider another example 2 here, that where only you might have a question like this, that if there is a function like only log x, then we cannot integrate by substitution. We can integrate here in integration by parts if we assume that this is product of two functions 1 into log x. Okay, then one is algebraic. You can see that in this order, logarithmic comes first, then algebraic. So log x will be the first function and 1 into dx is the second function. So into 1 dx, so this function going to be log x into integration of dx minus derivative of log x integration dx whole dx. So this thing is changed to log x into x minus 1 by x into x dx. So next step it will be x log x minus x plus c. Okay. Now if there is, suppose, product of functions in such a manner that after integration once it does not terminate, what will you do in that case? Example 3. Suppose you have a function like x square into e to the power x. Here obviously your suggestion will be x square is algebraic and e is exponential is e to the power x. So you take algebraic the first. But see, here if I take this one as first function, x square e to the power x is second function minus 2x, then it is not terminated here. Why? Because again there is product, we cannot integrate. So what we will do there, we will again use integration by parts by keeping 2 outside. So it will be x into e to the power x dx minus derivative of x is 1 e to the power x dx whole dx. Okay. So this thing is changed to x square e to the power x minus 2x e to the power x plus 2 e to the power x plus c. Okay. Now suppose we have product of this thing. X square into tan inverse x. Tell me how to do it by using Euler rule. If I consider Euler rule, then x square is algebraic, tan inverse is inverse. So inverse will be first one. We will have to write this manner. Tan inverse x minus derivative of tan inverse x is what? Into integration of x dx is what? Whole dx. So there will be tan inverse x into half x squared by 1 plus x squared dx. This integration all of you know. This will be x squared into tan inverse x by 2 minus half into, you write this way as x squared plus 1 minus 1 by, so there it will be x squared half into integration dx dx by 1 plus x squared. Okay. So if we integrate the last term, then the sum is done. Minus x by 2 plus, as a whole only one integration constant will be there. Okay. Now suppose an integration is of this form, that is e to the power, like e to the power x sin x. How will you do? Here the problem is none of the term will reduce after differentiation. So if you want to use by parts, you will take, let I equal to this whole thing, use by parts twice. Minus, okay, so this is going to be minus e to the power x cos x plus so y is equal to this. Okay, so this implies I equal to minus e to the power x cos x plus, again you take the same function as the first function, e to the power x into cos x integration is sin x minus e to the power x sin x. See the fun after this step, we have started with this integrand as a I, we are getting the thing I back. Actually it happens for all exponential multiplied by trigonometric functions. So you have to remember that we'll integrate it twice and e to the power x sin x. Then as the thing coming back on the right hand side, replace this side as minus I and then take I on the left side, it will be 2I e to the power x. So I is going to be e to the power x sin x minus cos x by 2 plus c, of course you will put there. So whenever product of one exponential and one trigonometric function is there, then you have to follow this method. In integrating by parts once only, it will never turn. So you have to do it by this method. Integrate twice. The same expression you'll be getting back on the right hand side. Replace this by I. Take it on the left hand side. Calculate I from there. Not only for this, even if you are doing it for this kind of sum, say e to the power x cos x is there, 3 to the power x sin x is there, and like if terms are bigger, like e to the power 3x cos 4x is there. For all these types, you will always follow this method, but the integrand will be considered as I. Then use integration by parts twice, bring the thing back on the left hand side, then integrate once more. Okay? See you again.